All right, this is the last FRQ in the review of particle motion, and you should have already done this because this was a quiz. This is question number 2 from 2018. This is a calculator-based problem, and so we can type the values that it gives us into our calculator and go from there. It says the particle moves along the x-axis with a velocity given by that gross expression. And because it's a calculator problem, I'm not going to write that down. We're just going to type that into our y list, and we're going to use that. And we're just going to express our work through function notation. And then it says the particle is at position x equals -5. I'm going to write this down just so we have a reference point. X equals -5 when t equals 0. So that's what was given there. And then for part A, it says find the acceleration of the particle at t equals 3. Well, we are looking for a of 3, and this is a calculator-based problem, so we just need to take the derivative of velocity at t equals 3. You should not be taking the derivative on your own because it's a calculator problem. You should just be typing in derivative of velocity when t equals 3. Your answer here is -2.118, and that is that. That was pretty straightforward. And you only get 1 point for having the correct answer there. So that's part A. For part B it says find the position of the particle at time t equals 3. So remember, the position of a particle is equal to the initial position, so we'll say x of a, plus the integral from time a to time t of my velocity function. Okay, so that's pretty gross there, but let me go ahead and write it this way, just so we can see it. Maybe we would say that the position at any time is equal to the initial position plus displacement. All right, so our position when t equals 3, so we'd say x of 3, is equal to our initial position, which was -5, plus the integral from 0 to 3 of v of t dt. And so we type that into our calculator again, and we end up with -1.760. Okay, so point values for this guy is actually worth a good amount of points. You would get 1 point for finding or expressing your integral. So basically having your correct integral expression. So having this part right here. You get 1 point for using your initial condition. Now, the reason that's usually separated is because a lot of times students will just say, okay, position is the integral of velocity. No, it's not. The integral of velocity is displacement, because remember, if you're going to just take the antiderivative of this, if it was an indefinite integral, it would be plus c at the end, and so the definite integral gives us displacement, not position. So you would get 1 point for the integral, 1 point for the initial condition, and then 1 point for your final answer. All right, for part C, it says evaluate the integral from 0 to 3.5 of v of t dt. Okay, so we'll just go ahead and do that. We plug that into the calculator and we get 2.844. And then it also says evaluate the integral from 0 to 3.5 of the absolute value of v of t dt. And so we end up with, on that one, 3.737. So that's pretty straightforward. That's easy. The next part of this, it says interpret the meaning of each integral in the context of the problem. So remember, the integral of velocity is just the displacement. So we would say that the particle's displacement for 0 is less than or equal to t less than or equal to 3.5 is 2.844. Now there are no units here, so that's it. For the second thing, the integral of the absolute value of velocity, that is the total distance. So we would say the total distance that the particle traveled for 0 is less than or equal to t less than or equal to 3.5 is 3.737. So that's the answer for part C. As far as points go, you're going to get 1 point for your two answers. So 1 point for having both of these numeric answers. You're going to get 1 point for the interpretation of the integral of velocity. And then you're going to get 1 point for the interpretation of the integral of the absolute value of velocity. So 3 points there. And then for part D, it says a second particle moves along the x-axis with a position of x of t, x2 of t, equal to t squared minus t. At what time are the two particles moving with the same velocity? So we had a problem a little bit ago that said, when are the two particles moving in the same direction? That's when the velocities have the same sign, so it's going to be an interval. In this case, it's saying when are the two particles moving with the same velocity? That means their velocities are the same. So we have to figure out the velocity of this guy. So the velocity of particle 2 is going to be the derivative of this, so it'd be 2t minus 1. And then because we want that velocity to be the same as the other velocity, we're just going to set that equal to the other velocity. So 10 sine of 0.4 t squared. 10 sine here. All over t squared minus t plus 3. So that's the equation we're solving. The way I would go about solving this is in your y1 list already. This you could put as y2, and you just find the intersection of those two things. And so we end up with t equals 1.571. That is the time when their velocities are the same. Point values for this, you're going to get 1 point for setting the two velocities equal to each other. Okay, so basically 1 point for this equation right here, and then 1 point for your final answer. All right, so that's all of number 2 from 2018. It's worth a total of 9 points here. 1 for part A, 3 for part B, 3 for part C, and 2 for part D. Go ahead and grade yourself. You're going to input your answers, input your score for the last 2 FRQs for question number 5 from 2017 and question number 2 from 2018. And if you have any questions on these things, please make sure you're asking me, because this wraps up our review of particle motion.